Hi everyone. Today we'll be discussing the LeetCode problem of the day, Pacific Atlantic water flow. Here we have M cross N rectangular island borders of Pacific Ocean and Atlantic Ocean. The Pacific Ocean touches the island in the top and the left, and the Atlantic Ocean from the bottom and the right. And the island is partitioned into height grid. So each cell represents the height of the island in that cell. That is above the sea level. And on this island, there's a lot of rain, so the water will flow in all directions, north, west, south, and east. And if we see for a particular cell, the water will flow to the neighboring cells only if the neighbor's height is less than or equal to the current cell. So this is what this paragraph means. So water can flow to the adjacent cell if it is less than or equal to the current cell. And in the border cells, the water can flow to the ocean no matter what the height is. So if there's water in all of these cells, it can flow to this Pacific Ocean. Or if the water is there in any of these cell, it will flow to the ocean beside it, no matter what the value is. And same thing for this and this as well. It will flow to this Atlantic Ocean. So we just have to return a 2D list of coordinates such that the rainwater from that cell will reach both Pacific Ocean and Atlantic Ocean. That means if we take this example 4, from this 4 the water can flow this way because 2 is less than 4, and then it will flow to Pacific Ocean. And from this 4 it can't flow here because this is greater, and it can't flow here as well. The only other option is it will flow here, and from this 2 again it will flow here, and here it can go to Pacific Ocean, or it can go to the right and then go to this Pacific Ocean, or go to the left and then go here or here. So we can see that from this 4, all we can reach is only Pacific Ocean. So we can't reach Atlantic Ocean. But what if we take the example as 5? So from this 5, we can see we can go to 3, we can go to 1, and we can reach Atlantic Ocean. And from this 3 again, from this 5, we can go to 3, we can go to 2, and we can go to Pacific Ocean. So from this 5, we can go to both Pacific Ocean and Atlantic Ocean. So this 5 will be included in our answer. So if we quickly see the first example, in this example, all these cells which are highlighted, from these cells, the water will flow to both Pacific and Atlantic Ocean. So if I quickly draw how they flow. So from this 5, it will flow directly to here and here. And from this 4, from 4 it will flow to Atlantic like this way, and to Pacific it will flow this way. So 5 and 4 are done. Now this 4, again Atlantic it will go here, and Pacific it will flow like this. 5 we have already discussed. Atlantic it can flow like this, and Pacific it can go like this as well. And for this 7, it can flow to Atlantic like this way, and Pacific Ocean this way, or even this way. And 6 can directly go to the Pacific Ocean because it is bordering the ocean. And to the Atlantic Ocean, it can flow this way. And finally, this 5, it can go like this and like this. So it is covering both the oceans. So in our answer, we'll just return our 2D list with all the coordinates from which both the oceans can be covered. And if you see the second example, we just have one element. So this is the Okay, what ocean was this? The left is the Pacific Ocean and the right side is the Atlantic Ocean, and this height is 1. So from this height it can easily flow through Pacific Ocean or even Atlantic Ocean. So we just return this cell in the answer. Now let's go over the approach. So we just need to find all the coordinates from which water will flow to both Pacific Ocean and the Atlantic Ocean. So one possible way is first pick a cell and from that cell perform a DFS. So from this 5, when you do a DFS, this will, from this you can know all the points you can cover. So if you start DFS from here, it can reach 3 and 3 to 1 and 5 to 3, 5 to 2, then here, 5 to 4, 5 to 2 and 5 to 1 to this one and here. Yeah, so from this cell, if you perform a DFS, you can visit all these cells. So once you have all this information, you can see that if any of these cells are visited, then the Pacific Ocean is checked, and if any of these cells are visited, then the Atlantic Ocean is checked. So if both Pacific Ocean and Atlantic Ocean is checked, then this cell we will add it in our answer. So we can repeat this process for all the elements. So total we have n into m elements, and for each element, if we want to do a DFS to know whether we can reach both Pacific and Atlantic Ocean, the DFS will take time order of n into m. So total, this complexity will be n into m whole square. And if we just check the constraints, n and m are 200. So the total complexity will be 200 power 4, which is 1.6 into 10 power 9. So this will not pass. So we have to reduce the time complexity further. So what we can do is, now currently we are calculating from each cell whether they can reach Pacific Ocean or Atlantic Ocean. So what if we think in a reverse order? So we know that in all these cells, from all these cells, we can reach Pacific Ocean for sure. So what we can do is, we can start from all these cells and do the DFS in a reverse manner. So that means from this cell, you will go to a neighbor only if the neighbor is greater than the current value, since you want to do the DFS in the reverse order. So you want to check the flow in the reverse order. So that means from all these cells, do a DFS and see what are all the cells you can reach. And similarly, from all these values, perform a DFS and see what all cells you can reach. And the common cells from both of these DFS, that will be your answer. So the complexity for this is, we are only doing the DFS the border number of times, and the border is just 2 into n plus m, and the DFS is n into m. So the total time complexity will be 2 into 200 plus 200, 400 into 200 square is 4 into 10 power 4. So total we have 3.2 into 10 power 7. So this will pass, and the complexity will be n plus m into n into m. So let's just take a dry run example of the DFS. So how the values are filled. Let me zoom it a bit. Okay, where is this? Yeah. So when you start a DFS, you will check all the neighbors, top, left, right, and bottom, and you will only iterate if height of neighbor is greater than equal to height of current. And also if it is not visited, then you will proceed with the DFS. So the first step is, for the Pacific Ocean, we need to perform DFS from all these starting cells. And we have to maintain a visited 2D array. Initially, all the values are false. And when you do the DFS from all these cells, the values will be populated. That what are all the cells that will be visited from these cells. So let's start the DFS from here. So we just mark it true. So the true, I'm just putting it with the red dot. So this is true. And from this, the neighbors are 2 and 3. And 2 and 3 are greater. So since it's greater, then we move because we are going in the reverse order. And from 2, we can go to this 2 because it's equal, and we can also go down. And from this 2, we can go to this 3 and 3. And from this 3, we can go to 5 and 4. And from this 4, we can go to 4. And from this 3, we can go to 5. 5 is greater than 3. From 2, we can go to 3 and 4. Okay. 3 and 4. So if we start the DFS from 1, this is all the cells we can reach. And now next we do the DFS from this. Since it's already visited, we skip it. Similarly, we skip this, this, and this because all of these are visited. Now let us do the DFS for these cells. So we check for 3, it's already visited, so we skip. Now we do for 2. So from 2, we can go to 6, and 6, we can go to 7. And from 7, we can't go anywhere because all the neighbors are smaller. So 2 is done. Now we check for 6, and 6 is already visited, so we skip. And finally, we check for 5. For 5, the neighbor is 1, so it's smaller, we can't go. And the neighbor 6 is already visited, so we stop. So from the Pacific Ocean, these are all the cells we can visit. So similarly, we'll do the same thing for the Atlantic Ocean. That means for all these cells, we will perform the DFS again. And this time we will maintain a different 2D visited array, which will store the visited values. So we again start from here and we do the DFS. So from 5, you can't go anywhere because all the values are smaller. Then you move on to 4. From 4, you can go to this 4. And that's it. Now for this one, from 1, you can go to 4, but it's already visited. You can go to 3. From 3, you can go to 4. It's already visited. And you can also go to 5. And from this one, you can also, from this 3, you can go to 4. From this 4, again, you can go to 5. And that's it. So 1 is done. Next 5, it's already visited, so we skip. Next 4, from 4, you can go to 2, and 5 is already visited. Now 4 is done. So next you check for these elements because these are also bordering the Atlantic Ocean. So for 2, you can't go to 1, and 4 and 4 are already visited. For 1, you can reach 1. And from this, you can go to 7. And you can also go to 5, but it's already visited. Again, this one, from this, you can go to 7, and you can go to 5. And from this 5, you can go to 6. And then 5 is already visited, so we skip this. So once we perform the DFS for Atlantic Ocean as well, so this is what we get. So if we see the array, we'll have like the true values wherever we have the blue. True to true, and all the remaining will be false. And similarly, here also we'll have all the red values will be true and remaining false. So once we have both the visited arrays for Pacific Ocean and Atlantic Ocean, we iterate on the array we iterate on each cell and see whether it is true in both this array, this matrix, and also this matrix. If it's true in both of them, that means from this cell we can reach both Pacific and Atlantic Ocean. So if we see from the example, all these cells have the true in both the arrays. So this will be your final answer. And if we quickly want to see for the next example as well, here it's pretty straightforward. We have just one cell, and yeah, when you perform the DFS, this will be true in the Pacific Ocean visited array, and also in the Atlantic Ocean, since this is also the neighbor, this will also be true. So it is true in both the arrays. So we will add this in your answer. Now let us quickly code the approach we've just discussed. So first, let me create a list which will store the answer. New array list. And let me get the row and column. Height dot length m will be height of 0 dot length. And let me just create a Boolean visited array for both Pacific and Atlantic Ocean. So Pacific will be mu n cross m. Similarly, we create for Atlantic Ocean. So after this, we have to perform the DFS on the borders. So let's just iterate on the borders. So first we are iterating on the row. That means we are iterating on these two borders. So in the row, we can start a DFS. The row will be I, column will be 0, and we will pass the Pacific Ocean Rudy list, and also the heights. And while we are doing for the Pacific Ocean, we can also do the same thing for the Atlantic Ocean as well, but the column will be m-1. So that means this last column. And also, like we discussed, we should only do the DFS if the element is not already visited. So if Pacific of I and 0 is false, then only you will perform the DFS. And similarly, if Atlantic Ocean of I m-1 is false, then you perform the DFS. So now let's just quickly fill the DFS function. It won't return, its type is void. DFS int I int j, and Boolean array, let's take it as visited, and then finally the heights. So once we do the DFS, first we can just mark it as true, and then we'll just perform the DFS for the neighbors. And to iterate on the neighbors, we can also create a 2D directions array equal to, so again from the cell, if you want to, you want to go in all possible directions. So if you want to go to the top, the row decreases and the column remains same. And if you want to go to the bottom, row increases, column same. And if you want to go to left, row remains same, column -1. Similarly for the right, row same, column +1. So now we can quickly iterate on the directions array. X equal to I plus directions of I0. Similarly for Y, it is J plus directions of 1. And since we can move top, bottom, left and right, if we move, from this cell, if we try to move top, we are going out of the grid. And if we go right, also we are going out of the grid. So there's a chance that we can go out of the grid. So we just need to check if we are in the grid or not. So I'll just create a function for that. Check X, Y, and the boundaries will be boundaries will be heights dot length and heights of 0 dot length. If the check is true, so that means if it is not going out of bound, and visited of X, Y is false, that means if it is not visited, then we'll just perform a DFS for X, Y. And that's it. So the DFS is done. So we just quickly need to fill the DFS, the check function as well. So its return type will be boolean int X, Y, N, M, and then return X should be greater than or equal to 0 and X and Y greater than or equal to 0. X is less than the rows, Y is less than column. Yeah, so the DFS is done, and we are doing the DFS. Currently, we did the DFS for the Pacific Ocean first column and the Atlantic Ocean last column. So we also need to do it for the first row and the last row as well. So for that, let me just duplicate this loop, and here we will iterate I less than M. And for the first, since we are iterating on the columns, the row remains same, and row remains 0 and the column changes. So this is 0, this is I. Similarly, we have row remains n-1 and the column keeps changing. This is n-1, column keeps changing. So once we are done with the DFS, we just need to iterate on the Pacific or the Atlantic Ocean. I0, I less than n plus plus. So if Pacific of I and J is true, and Atlantic of I, J, if both are true, then we will add this I and J to our answer. So answer dot add arrays dot as list I comma J, and at the end let's return answer. I equal to, okay, I is already used, so let's take I and D. This will be I and D, I and D. And this should be heights. And what else? ATC. This should be ATL, Atlantic Ocean. ATL. Here also ATL. Okay, let's giving us wrong answer. Let's quickly check the code. Okay, so while performing the DFS, we haven't checked the condition where from this element we can go to the neighbor only if the neighbor is greater than or equal to the current element. So that also we have to check. If it's not visited and heights of xy should be greater than equal to heights of I. Okay, it's going out of the page. Heights of xy should be greater than heights of ij, then only we can perform the DFS. Let's test now. Okay, what is this? Again, heights. Yeah, it works. Let me submit. Yeah, it works. Finally, let's do the time and space complexity analysis. So first, for time complexity, we are running a loop, and on the boundaries we are performing a DFS, and the DFS takes order of n into m, and we are doing it only for the boundaries, and the boundaries are n plus m. So the total complexity will be order of n plus m into n into m. Also, this will take order of n into m, but this will be added in this, so it will be ignored. And for the space complexity, we are creating a Boolean 2D array of size n into m, so space will be n into m. I also have the code in Python. If anyone wants to view it, I'll add it in the description as well. And let's catch up in the next video.